All right, you can see this is a set of notes on hydroelectric power, and that's important for this section on electromagnetism, and it's also important for our next section, which will be on how we use electricity in our house. So here is a diagram of a generator. You have to be able to sketch this and label it, so this is something you're going to have to commit to memory. Now, what we need is something to spin our generator shaft. And that could be from nuclear power, it could be from hydro, it could be from wind power. All those things have in common is they spin a generator shaft. And then the rest of it, well, they'll have in common as well, because we're taking that mechanical energy and we're ultimately going to make electrical energy. That's what the AC output says. So over here, we have these coils of wire, and it says they're stationary. And in those wires, we're going to try to make electrons move. And the way we're going to do that is magnetism is going to be generated in this bar here. And what that's going to do is, as we have a changing magnetic field, it's going to force electrons to move in one direction or the other. So generator shaft's very important. We have an armature here, that's where we've created that magnetic field that's going to spin, and we have these wires waiting for electrons to be pushed one way or another. I'd say, well, why don't we just have wires hooked up and have this thing spin? But you could see very quickly the wires would all coil up. So to maintain constant contact, we have these rings and we have these brushes. And that means from our power supply, we're creating this electromagnet. And it's a constant supply because of the brushes and the rings. So we apply electricity, generator shaft spins this, we spin our magnetic field, and we push the electrons in one direction or the other. Now what you have to understand is it's alternating current, because for half a turn, this side pushes at or makes the electrons move in one direction, but this will have the opposite polarity, so when it swings down, it'll push the electrons in the opposite direction. So it goes back and forth very quickly at a frequency of 60 Hertz. Now, what we've done is we've taken this equipment and we've put it here inside our dam. So if you ever get a chance to do a tour of a hydroelectric dam, say in BC, it's a lot of fun to go and take a look at the inner workings of it. Hopefully you don't go in the penstock while it's running. So this is our lake, our water reservoir. Here is a channel or a tunnel for the water called the penstock. And that flowing water, that mechanical energy, will make our generator shaft spin. We have electromagnets, we have wires, and the spinning electromagnet will cause alternating current to be produced that can be shipped into our electrical grid. Often in a dam you'll see water if the river or lake is high, you will see water going over top, and that's a spillway to prevent the dam from being destroyed. So that's a brief look at how we get hydroelectric power.